We're gonna talk about like basically. So I've been doing competitive programming for 2 years, and I've realized that I've made like a lot of bad habits, and those habits have like slowed down my progress. And over 2 years, I've realized like a good way to practice, and I want to share it with particularly like freshmen and underclassmen who are interested in competitive programming. So I really recommend that you listen to what I'm saying, as you can avoid the same mistakes that I made. And just to shout out a few people, I had Tony and Victor, who are really good at competitive programming, help me like refine the slides, and I also had David help me like prettify all the slides because they were looking pretty garbage before then. But we're gonna go over really just 4 main things to practice. First, we're gonna establish like what is competitive programming, right? And once we establish that, we'll show like how to choose problems. Because of course, like many of you freshmen are in CSA, but like that is not like enough to sort of delve into competitive programming. Like you have to do more, you have to choose the right problems. And then once we talk about like what problems you should do, we should be talking about how do you solve these problems. So 3 is extremely important. That's like talking about how do you reflect on a problem. Like 2 people can do the same amount of problems and like the same types of problems, but it's what you do after that really has that effect in your problem solving ability. And then after we talk about how to like solve problems thoroughly, we'll talk about like what to do now. So let's get into what is competitive programming. So really these are the 4 main things. Competitive programming is like a type of problem solving. So if you know like math is, it's kind of similar to that. You basically just have a problem and you're just coding it on a solution. It's not really like project based, it's more of like algorithmic and thinking based. And so it's a mind sport. So like the best competitive programmers in the world, they like travel all over the world and they take competitions, and it's really like once you like as you get better on it, you'll be like more serious about it. And the main thing about competitive programming is like algorithms and data structures. So that's sort of the whole point, because we need to write efficient code. Like a problem can have a very obvious solution, but that solution can take too much time. So competitive programming allows us to write, it allows us to open our creativity, because when we constrain things, we can think outside of the box. That's really what competitive programming is. So the next slide, we're gonna really get into it now. So if I had to restart competitive programming, like a lot of like getting, so there's like 2 types of people who do competitive programming when starting, right? Some of these people are like really good at math, and not just like school math, but like contest maths like AMC and all that stuff. And those people usually find it easier to like pick up competitive programming because they've already established that problem solving basis, right? So for example, for the first division of USICO, you'll find out that it's not like you should actually spend less time like coding to pass this. Like you should spend more time establishing your problem solving. So I do know you're freshmen, you guys probably want to advance quickly and you guys want to do like competitive programming. So I'm not saying to like sweat math, but I do recommend to be sort of solid at math, because if you want to like continue competitive programming, you're gonna have to be like at least pretty decent at math. Like math cannot like hurt you. And I've also seen like tremendous results from people who have like worked a lot on math, and then they go into competitive programming, they pick it up very easily. So what I recommend is if you want to do something with competitive programming, math is definitely a good combination. Victor can tell you more about that because he is a sweat at that. But basically, you'll notice that not all math topics are like useful for competitive programming. So like
Geometry.
Geometry, like for beginners, geometry is not important. As you get like really high into it, geometry, like that stuff is important. But really what you want to focus on is like algebra and number theory is definitely important, and counting and probability is probably the most important, because a lot of times problems will ask you find the amount of ways to do X, and that is really important. So if you're really good at counting, stuff like dynamic programming will come very natural to you. So that's why math really sets the foundation. So if I had to restart, like maybe in middle school, I would start like really taking stuff like this seriously. And in 9th grade, you can still do that. It might be a little bit too late if you do it in middle school, but you can still sort of like focus on that stuff. Now, if you're like in bronze and you're trying to get to silver, just work on general problem solving. Like don't try to learn like advanced algorithms or like advanced techniques. Just, I'm telling you, I know people who don't even do competitive programming legit, and they easily pass bronze, and that's because they're really good at math. So I think you get the point here. So basically, all you really need to do is like learn how to learn. You need to learn a language, and CSA does a good job with that. You guys go over like Java, like the fundamentals of Java, and I think it's like a really good class in terms of like learning how Java works. And if you know a thorough amount of CSA, you don't even need to know like inheritance and all that stuff. If you just know like basic logic, you should be able to get by practicing. But once these are kind of done, then now you have that sort of foundation to start on problems. And then I will also stress that for bronze, it's sometimes the problems are like pretty random. Like silver and above, like there's actually like algorithms that you can study for. But bronze is a little bit like random. We'll get into that later, maybe later. But really, just bronze. I cannot emphasize enough that problem solving and then just implementation will get you pretty far. Like you'll be able to pass bronze very easily. So this next slide, and then. Yeah, like I said, you should be able to pass bronze, and I already talked about like why like being good at math and then just learning a language pretty much gets you into silver. And then I'll talk about this is also a very new mistake. So like you should not be learning like Dijkstra's algorithm if you just like learned how to print hello world. You should make sure that you're not trying to focus like some people might tell you that focusing on harder things will make you better than easier things. That's wrong. You want to focus on your fundamentals so that when you do those harder things, those harder topics, you can learn them easier and you're not like wasting so much time because you lack fundamentals. And contrary to popular belief, Aiden thinks that, or Aiden used to have this thought that UCO is a memorization game of who can implement the most algorithms. This is definitely false. Most algorithms, like the whole point of an algorithm is just to do something relatively quick and fast so that you don't have to like waste time actually doing the algorithm. Like the algorithms are just a tool for you to use. Like the main core of computer programming is actually the problem solving. Now, enough of all this talk. What resources should I use? So over like the years, I've used a lot of like cloud resources. So I would say like all the bad resources, like you should not use, like if you come across like UCO training or UCO, actually we'll just get into the resources. So this is extremely important. Like even if you spend hours and hours writing like CSA problems, you will not pass. You probably will not do well in UCO because you need to make sure that you're working on good problems. So I just have, these are like the 5 big ones that a lot of people use. There's like some smaller ones, but these 5 big ones a lot of people use. We'll talk about wasting UCO problems, saving them, and then we'll talk about like code forces, AtCoder, CSES, not to overwhelm you guys, but these are just the main resources. And we'll also talk about like code forces using a rating, and also outside of just UCO, there's actually, unlike other Olympiads, you can actually do multiple contests like literally every week, and you don't have to wait like 1 year to like take the test again. So that's a good thing about competitive programming. And then another thing is don't be biased when choosing your problems. Like don't choose problems that you know how to do well. Like if you just like skew all your practice to your strengths, you probably do that because you want to feel good that you're actually improving, but you're deceiving yourself, right? You need to focus on like problems that actually make you like think and like are good for you, right? And then we'll go into UCO guide. So I'll just quickly go through this. This is very good when you just like promote a division. So when you just promote a division, you have to like know new concepts. Like if you promote from bronze to silver, now that's a good time to learn like basic graph theory, like how to iterate through a graph. And this website is very good for that. When you just want to like jumpstart your knowledge after promoting to a division, use UCO guide. It's very important, and these people are extremely qualified, like more qualified than anyone in this room. Like people who've had like extreme success. So like one of the UCO writers actually made this website. So I do recommend using this a lot, but this does have some downsides to it. Even the people who made it conceded this too, is that it doesn't really guarantee promotion. And I know this for a fact because in 9th grade I finished like half of the silver guide, and I thought it was so cool that I was gonna like sweep through silver. I got like a fat 0 on that contest. And so I recommend like don't be like that guy who's like, oh my god, I finished the prefix sums module on UCO guide. Now I can solve any prefix sums problem in the world. Like, don't be deceived by that. That is very like noob. So yeah, overall very good when you just get into a division because you can work on those like topics, right? But this should not be your only source of preparation for sure. Don't like be too reliant on this. And then next one, oh yeah, and also another thing about UCO guide is that sometimes knowing the technique to solve a problem can hurt your performance. For example, like if you know this is a graph theory problem, then all your thoughts will be focused on graph theory and not other topics. So you're sort of like, you're priming your brain to think in a restricted way. Like you're restricting the way that your brain can think. So sometimes knowing the algorithm is not good because you want to be able to recognize that for yourself. So that's also another downside between USIGO Guide. Now CSCS, I think CSCS is pretty like straightforward. There's over like 250 problems, and they're all standard problems. What I mean by standard is that the problems, like, they can all be searched up on Google and you can find the solution. Not that they're, standard does not mean easy, standard just means like a well-known problem, and you can just pretty much Google the solution to it. And there are no direct editorials, so for a lot of these resources, there's usually like a solution attached underneath it, and you can just like press a solution and then boom, you have that. But there are ways around it. There are a bunch of Indian dudes on YouTube who post like very good YouTube videos. Not to like, it's just a matter of the fact there's a bunch of Indian dudes. And so if you want to find those Indian dudes, just Google the problem and you will find like, and if you, yeah, let me just stop right there. So there are no storylines for problems. Storylines are very annoying. Like maybe in the beginning when you just start competitive programming, you're like, oh, this is very cool. We have a cow and all these things. But once you start doing problems, you're like, I don't care about the story. I just want to like actually do the problem. So this is very cool because the problems are very short. And there's also, just keep in mind when you do this, work linearly down. The problems usually tend to get harder as you go down the list, like logically, but this does have a huge difficulty range. So again, the point of this, the big idea to get from this is that this problem is good for building your fundamentals, right? Knowing the well-known tricks in competitive programming. So I recommend this as well. Then the next one, you have code forces. So this is my personal favorite because this one is like, maybe, I'm not sure if it's good for just when you just start out because it is a little bit difficult. Even the easier problems are not like, they're not like, the easiest problem on code forces is probably way harder than the hardest problem on CSA to some extent. That's true to some extent. But I would say that this is very good because the new era of USIGO has been approaching like code forces styles of problems. So what I mean by that is that the problems are USIGO, like the USIGO staff people are not caring about like how much you can code, they're caring about how much you can think. And so you'll notice that a lot of these problems on here, they have like sometimes when I was doing a problem, I was thinking about like how could I solve this, and my logic was like 50 lines long, and then you open up the solution, it's like 2 lines long. That's pretty much code forces for you. You just need to focus on thinking more. So again, this is really good for USIGO. Like this is like really, really good for USIGO. You can use this, and this is my personal favorite. We can have a whole meeting on how to use code forces, but yeah, the main thing is just the problems are approaching that style. And then ActCoder, I'm not gonna spend too much time on this because I haven't really used it, so I can't really talk too much. But this is also another great resource, similar to code forces, but it uses more like math and stuff. So if you use that, just keep in mind it's there. Also use these to like see the difficulty of the problems. That's a good website. And then USIGO, these are the best quality of problems. I don't think this is biased because if you think about it logically, there are like, for one division, there are like 12 problems, right? 3 times 4 is 12. And there's 12 problems for one division, and these problems have been worked on for an entire year. So these are not going to be like, unoriginal problems. Usually they won't be unoriginal, especially like more recent contests. These are going to be like well thought out problems, and for that reason, that's why USIGO is very difficult, because these are well thought out problems that are not just thought out like on a Saturday morning. They like work on these problems for a whole year, and most of you probably want to get into USIGO, maybe for college apps, I don't know, or to have fun. But yeah, there are 4 divisions: bronze, silver, gold, platinum, and yeah, just try to set a goal for which one you want. Obviously, most people would want platinum, but just make sure you're putting in enough work to achieve your goals. And then again, I will stress that this is the trend for almost everything. More recent problems are going to be more difficult than less recent problems. So I think this era is most realistic of the new era today. And use problems sparingly. Like, don't use USIGO problems when you're like really bad, or because like you don't want to waste them because they're very like there's you know there's not that as many of them. So just use them sparingly. And then solving problems. So now you guys know the resources to getting good. These honestly, these resources are definitely more than enough. Like you will not be able to finish everything on those websites. Even the top programmers, definitely that's impossible. How long should you spend on a problem? There's no answer to this. Like when you're solving a problem, some problems take more effort than others to sort of reach that click in your head. So sometimes you just have to like kind of think about it or play around it for longer. So some people say like spend like no more than 20 minutes. That's not necessarily true. However, don't like spend 3 hours on one problem. That's a very bad habit because you could have done 3 other problems that still challenge you. Maybe not as much, but they still challenge you, which is more productive. Spend enough time actively thinking, right? This does not mean like looking at your paper and not knowing what to do. Like we want to actually be trying new things. Because if you don't do this, then like a lot of that's just wasted time. Like you spend 1 hour just looking at your paper and doing nothing. And then yeah, just use hints. These are a little bit of details. You'll notice this as you do this. And another important thing is don't jump into implementation when you know the gist.
It is now 3 o'clock. If you are not with the coach, director, sponsor, or in tutorials with the teachers, you must now exit the building.
Yeah, so you'll probably figure out this one by yourself, just as you start programming, but this is a big one too. So next one, problem graders. I'm not gonna like go into depth into all of these. Just know when you submit a problem, they have different verdicts. So accepted means you got the problem right. Wrong answer means that you're wrong. And then time limit exceeded means that you time out. Memory means you've stored too much data over like the constraint. And then these mean compile runtime error. You could just honestly just redo this. It's just you'll notice this as you do more. Now, the most important thing, even the you can have all these good resources, all these good strategies to solve problems, but if you don't reflect on why you didn't solve a problem, then you'll barely improve. So there's 3 things that I've noticed, and they're sort of in increasing difficulty. Understanding how the solution works, right? This is what kind of separates like school math and like competitive math, right? A lot of times in school math, you just need to understand like how it works, and you're not required to understand why it works, right? So you have to understand how it works. You have to know like what they did. You have to like understand that. But after that, you have to know why is this true. But there's even a higher level, is not only knowing why a solution works, you have to know how to come up with the solution. So this is looking for motivation. Number 3 is the most difficult part, and this is why it's hard to improve because, for example, a lot of people in practice, they'll be able to understand their solutions, the solutions to the problems if they don't get it wrong. But understanding how to come up with that solution is very difficult, and that's something that is not going to be on the solutions. You're just gonna have to like think about it yourself, because that's just like how you think and how your brain processes. You just need to think about how to motivate it. That's gonna be pretty hard. And then yeah, this is a stroke of genius versus maintaining rigor. So Mr. Meyer said that, kind of inspired me, but stroke of genius means that like you sort of got lucky on that day and you solved the problem like on accident sort of, and you sort of just had good intuition. But to make sure that you're not accidentally like solving problems or getting lucky, just make sure that you're proving your solutions. This maintains rigor, and so that you don't have any like small gaps in your thought process. But yeah, that's pretty self-explanatory. And then should be what to do now. Just grind. Like that's pretty much it. Like once you know how to do, literally, once you do these things, the people who are better, they might be naturally better, but like just grind. Like at your own time, like don't pressure yourself, but there's really only like one thing to do, grind, right? And then classes versus self-grinding. Personally, I don't like classes too much. That's just my opinion. I think self-grinding is better, because even if you do classes, you still have to be motivated. So like might as well just not like spend $3,000 on a class that like doesn't help you at all. And then yeah, that's it. Questions?